Good day, grade 12 learners. Welcome to today's technical science lesson. My name is Lebogang and my surname is Teledi. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So now for today's knowledge area, we'll be focusing on chemical change, which consists of 28 marks. And for today's topic, we'll be focusing on galvanic cell, which is under your electrochemistry. And galvanic cell will be on paper 2, which is then question 6. And it consists of plus minus 15 marks there. Okay, now this is the mark allocation for paper 2. Paper 2 will consist of section A, which has 5 multiple choice questions, and it consists of 10 marks there. Then we have your section B, which consists of structured or long questions and has a total of 65 marks. Now the total for paper 2 will be 75 marks, and that is with a duration of 1 hour, 30 minutes. Okay, topics to be covered in paper 2 will be under the content of matter and materials, which has 47 marks and has a percentage weighting of 62. And we also have chemical change, which consists of 28 marks and a percentage weighting of 38 there. In terms of the examination guideline, this is what you need to know that is under your galvanic cell. You need to know oxidation and reduction, and you need to know the following definitions or terms. You need to know oxidation, you need to know reduction, oxidizing agent, reducing agent, and electrolysis. Okay. Then next, you need to know how to define the cathode, the anode, and you need to know how to write down the following reactions. That is your oxidation and reduction reaction, and also the overall cell reaction, that is by combining the two half reactions. And then again, according to the examination guideline, you need to know how to assign oxidation numbers. Know the rules for assigning oxidation numbers. Assign oxidation numbers, and that is to various molecules. And then the last part now says understanding the processes and redox reactions taking place in a galvanic cell, and also the standard conditions there. Now, this is what you already know. So your pre-knowledge from grade 10, you had already learned about pure substances, which is then your elements and compounds. For elements, it says a substance that cannot be broken down into simpler substances by chemical means. So any element that you see on the periodic table, so that will be any single element that you see on the periodic table. So it can be your sodium, which is Na, your Zn, which is your zinc. It can be the letter B there, which is your boron, Cl, which is your chlorine. So any single element there on the periodic table. Next, we have a compound. It says is a substance that consists of two or more elements that are chemically bounded in a specific ratio. For example, if we have H2O, that is no longer one element, but it is what? It is two elements. So hydrogen is the one element and the oxygen is the other element. What is another example that you can have for your compound? You can also have what? You can also have your CO2 there, which is your carbon dioxide, okay? So if it's CO2, carbon is the one element and oxygen is the other element. Another example can be what? It can be like your KCl there, which is your potassium chloride. So K is the one element and the chlorine is the other element, or the Cl is the other element. So that will then be defined as your what? As your compound there. Then from grade 10 again, you learned how to name compounds, and then the table of negative and what? And positive ions, okay? Then it says the charge of simple ions can generally be deducted from the group number. So if you look at your periodic table, group number 1 on periodic table, you will see that it has a charge of what? Of +1. Group number 2 on the periodic table, it has a charge of what? It has a charge of +2 there. And then group number 3 on the periodic table has what? +4. Group number 4 or 14 has +4 there. Group number 5 or 15 has -3. 6 or 16 has -2. 7 or 17 -1. And then group number 8 or 18, there will have a charge of what? Will have a charge of 0. Now, learners, if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. If you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908 there. Now again, this is now your periodic table. So you need to make sure that you have your own periodic table so that even when you study, you are able to refer to it. Okay, so this is what we're talking about now, to say that this one here will represent what? Will represent your group number 1 there. So group number 1 has a charge of what? Has a charge of +1. This is now group number 2. It has a charge of what? +2. And then these ones here, so from group number 3 to group number what? To group number 12, those are your what? Those are your transition metals. So we skip those transition metals, and then we are going to use what? We are going to use group number 30, or also called group number 3, has a charge of what? It has a charge of +3 there. Then group number 4 has a charge of +4. Group number 15 or group number 5 has a charge of what? -3. Group number 16 or group number 6 has a charge of -2. Then group number 17 or group number 7 has a charge of what? -1. Then group number 18 or group number 8 will therefore have a charge of 0 there. So you need to make sure that when you use the periodic table, you are able to identify all the charges. So when we say group, basically we are saying that all the elements that are within this column, but instead of us talking about a column, we are going to use the term what? Group. So all the elements within this column going down will therefore have a charge of what? +1. All the elements that are in this group here or in that column, they will have a charge of +2. Then going down again, all the elements +3, and then all the elements on group number 6 and so on up until group number what? Up until group number 8 there. Now again, you also learned about what? Matter and material. That is your metals, your metalloids, and your non-metals there. So you know that your metals are where? They are on the left-hand side of the periodic table. Then you have the metalloids that are in between the metals and the non-metals. Then on the right-hand side of the periodic table, that is where you have your what? That is where you have your non-metals there. So it says here metals are what? Metals are good conductors, okay? And they have between 1 and 3 electrons in their outer energy. These are called the what? These are called the valence electrons, and they are loosely bound there. So when we say that they are loosely bound, it means that metals will be the ones to donate the what? To donate the electrons there. Then we have what? We have non-metals, which are found on the right-hand side of the periodic table. Non-metals are poor conductors. Okay, it says they contain 4 and 7 what? 4 and 7 valence electrons. Okay, so 4 and 7 valence electrons, it means that we are now talking about what on the periodic table? We are talking about group number 4 to group number 7 there. And then with the metals, it's group number 1 to group number 3. So it says we call them what? We call them the insulators. That is now your what? That is now your non-metals there. It says an exception to the general rule that non-metals do not conduct electricity is what? Is graphite, okay? Graphite. So another important term that you need to know is the word what? Is the word carbon. So remember, carbon on the periodic table is what? Is your letter C there. So you need to make sure that you keep that in mind, that when we talk about carbon can also be referred to as what? As your graphite. And which graphite is this? This is the very same graphite that will be used in what? That will be used in pencils there. Okay. Next, in terms of the pre-knowledge for grade 11, this is what you have already learned. It says oxidation numbers of atoms in molecules, okay? So we spoke about those oxidation numbers. It says explain the meaning of oxidation numbers, assign oxidation numbers that is in various ions. So how will you assign oxidation numbers? You just have to look at the group numbers there of whatever element that you are given. Then redox reactions from grade 11, you were able to describe redox as oxidation or reduction reaction. It says as involving what? As involving electron what? Electron transfer. Then it says describe a redox or oxidation reduction reaction as always involving the changes in what? The changes in oxidation numbers. And then you needed to, it says identify a redox reaction and apply the correct terminology to describe all the processes. So again, we are going to discuss all of that now. That is in terms of the grade 12 work that you need to know. Right, so we have what here? We have redox what? Redox reactions, okay? It says redox is an acronym for what? For reactions. So what is it that we can see from this redox? We can see the word red, which stands for what? Reduction. And then we can also see the word what? Ox, which stands for what? For oxidation. So when you now combine the two, that is now your redox or reduction and oxidation what reaction. Now it says redox reactions are reactions that involve what? Electron transfer. Okay. It says electrons will easily be transferred by the what? It will easily be transferred by the metals. Remember we said that where do we find the metals? We find the metals on the left-hand side of the periodic table. So it means that if the metals are transferring transferring the electrons, it means what? It means that the non-metals will be the receivers of what? Of the electrons. Now it says metals will be used as what? As our electrodes, as they can also conduct what? As they can also conduct electricity. Now we have what we call a galvanic cell or a voltaic cell, okay? So if in the exam they ask you what type of a cell is this, or maybe they use the word what? Voltaic cell, then you need to keep in mind that the word voltaic, it simply means the same thing as what? As a galvanic cell. Now it says here, electrochemical cell. So the definition now of a galvanic cell, it says electrochemical cell. So keyword here, very important. So this is an electrochemical cell that does what? That converts what? Chemical energy to electrical energy. So that is very, very important. You need to make sure that you get your definition correct, because remember, definitions are what? They are 2 marks or nothing. So it needs to be exactly the same way as it is there on the examination guideline. Okay, so number 2, what is it that we need to note about a galvanic cell? A galvanic cell is spontaneous. What does the word spontaneous mean? It says it is a cell that will occur on its own, okay? So in the exam, the question can be, is this cell spontaneous or non-spontaneous? So because remember, we also have what? The electrolytic cell. So, but then you will have to note that with a galvanic cell, it's going to be what? It's going to be a spontaneous cell, meaning that it occurs on its own. Okay, then number 3 here, when it comes to the galvanic cell, what is it that we need to note? We need to note the energy conversion. In the exam, they will now say, what is the energy conversion in terms of the galvanic cell? Then you know that it's going to be what? It's going to be chemical energy to what? To electrical energy. And where do you get this conversion? This conversion, you easily get it from what? From the definition there. Because the definition defines it as what? Electrochemical cell that converts chemical energy to electrical energy. So it should be easy for you to now be able, if you know the definition then, and then they ask you about the energy conversion, then it should be easy for you to be able to answer there. Okay, so on this picture here, what we have now is what? Is our galvanic cell, but we are going to go more into detail. For now, we just need to know what? The definition, that it's a spontaneous cell, and we also need to note the what? The energy conversion. Okay. Next, we have definitions there. So it says, in terms of what? In terms of electron transfer. So this is what we need to note in terms of electron transfer. It says here, oxidation occurs when an atom or an ion is doing what? So when an atom, when we speak about an atom, what are we speaking about? We are speaking about any element there on the periodic table. So it says when an atom or an ion, it does what? It loses what? Electrons. That is what that is when we can refer to it as what? As oxidation. Okay. So this can be an example of what? Of an example of oxidation. Okay. So when an atom or an ion is losing an electron, then you will see that we are able to represent the electrons way on the right hand side of the equation there. So remember, on the left hand side we have what? We have reactants, and then on the right hand side we have what? We have our products. Then we have what? Reduction. It says reduction occurs when an atom or an ion is gaining an electron. Okay, so then when we speak about the gaining of what? Of electrons, then we can represent what? We can then represent our electrons where on the reactant side, or where? On the left-hand side of the half reaction there. Okay. Now it says oxidation and reduction always take place simultaneously. One cannot occur without what? Without the other. So simultaneously just basically means what? It means that oxidation and reduction, they are going to occur at exactly the same time. Whenever we have oxidation, there will also be what? There will also be a reduction at the same time. So now this is how we can then remember in terms of the electrons there. So we can use Leo, which is then the loss of electrons is what? Is oxidation. So the L is what? Is the loss. The E is electrons, and then the O is what? Is oxidation. Then next we have what? We have the word oil there. So oil is what? Is oxidation is what? Oxidation is loss. Then you remember that when we say oil, oxidation is loss, but the loss of what? The loss of electrons, okay? And then we have what? GER, or gain. So the G will stand for the gain of electrons is what? Is reduction. Or you can also use what? You can also use reg, which is what? Which is reduction is gain, but it's the gain of what? The gain of electrons. So you can maybe use this combination of oil, reg, or the other combination of Leo and what? And Ge. Okay, so oil reg, you will remember that its oxidation is loss. The loss of what? Electrons. And then the reg is what? Is reduction is gain, and the gain of what? Of electrons there. Okay. Next it says in terms of what? In terms of the oxidation numbers. Okay. So we are still defining what? We are still defining oxidation, and then we are still defining reduction. So in terms of oxidation numbers, it says oxidation increases in oxidation number. Okay. So when we look at this zinc atom here, so if it does not have a charge there, it therefore means that our charge will be what? Our charge will be zero there. But now if it has a charge there, it means that we are going to use what? We are going to use that very same charge there. So let us see now, when we say increase in oxidation number, what does it now mean? This one is a neutral atom. It does not have a charge. So because it does not have a charge, it therefore means that the oxidation number is what? Is zero. But this one, because it has a charge, the oxidation number is what? Is 2 plus there. So if we are moving from 0 to what? To 2 plus, it therefore means that there was what? There was an increase in the oxidation number. Why are we saying so? Because the number 2 plus is bigger than what? Is bigger than the number 0. So therefore there was an increase in the oxidation number. Okay. Next we have what? We have reduction. So reduction, it says a decrease in the oxidation number. So let us now see. With this one, we are moving from copper 2 plus to a neutral atom. So an atom, it means what? Any element that you see there on the periodic table, or any single element that you see there on the periodic table. Okay. So where are we moving to now? We are moving to this copper, which has which is a neutral atom, or has an oxidation number of what? Of 0. If there's no charge, the oxidation number is what? Is 0. Okay. So let us now see. We are moving from 2 plus to 0. 2 is a bigger number than what? 2 is a bigger number than 0. Okay. So therefore, if 2 is a bigger number than 0, then what is happening in terms of the oxidation number? It therefore means that there is a decrease in the oxidation number. This one, oxidation, we move from 0 to 2 plus, increase in oxidation number. This one, the copper, we're moving from what? From 2 plus to what? To 0. So therefore, 2 plus to 0, there is a decrease in the oxidation number. Okay. Next, we have oxidizing agent. It says a substance that does what? A substance that gains electrons, or the substance that is what? The substance that is reduced there. So when you think of a substance that is reduced or a substance that is gaining electrons, which one do you then think of? Remember, we said oxidation is what? Is oil. And then we said reduction is what? Is rig. Okay? So oil is then what? We said oxidation is what? Oxidation is loss. But then with reduction, we said it's rig, which is what? Reduction is gain. So from the definition here, it says a substance that does what? A substance that gains what? That gains electrons, or a substance that is what? A substance that is reduced. So what does it mean? It means that when you want to identify the oxidizing what? Agent, the oxidizing agent will be part of, or you are going to get it from what? You are going to get it from your reduction half reaction. And the thing about agents is that agents are going to be on the left-hand side of the reaction there. Okay. So if this is now your reduction half reaction, it therefore means that Cu2 plus will represent your what? So Cu2 plus will represent your what? Your oxidizing agent. Because we are saying that agents are always your reactants, but that is when you have the correct half reaction of in terms of oxidation, or the correct half reaction in terms of what? Reduction. Okay. Next, we have what? We have the reducing agent. Reducing agent, it says a substance that loses electrons, or the substance that is what? That is oxidized. Then this one, which one can you relate it to? A substance that loses electrons, you can relate it to what? To oil. Oil is what? Oxidation is what? Oxidation is loss. Loss of what? Loss of electrons. Okay. So it therefore means that we are going to relate this reducing agent to what? To oxidation. So oxidizing agent, then we relate it to what? To reduction. Okay, so with the reducing agent again, it says a substance that loses electrons, so it means that our focus is on the half reaction of what? Of zinc, or the substance that is what? The substance that is oxidized. So again, we said what? We said that as long as you have the correct half reaction in terms of what? Oxidation, then your agents will be what? On the left-hand side, or your agents will be what? Will be your reactants. So it therefore means that Zn will be your what? Zn will be your reactant, will therefore be your reactant. And if it's your reactant, it will therefore represent your what? Your reducing agent there. Okay, learners, again, if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. So if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. Now it says an electrode. So now we have more definitions. It says an electrode is an electrical conductor. Okay. So remember when we introduced, we said what? We said we are going to use what? We are going to use metals, or metals will be used as the electrodes. So in this case, this one here, this one, the Zn, this one, and the copper, they are representing what? They are representing our electrodes. So it therefore means what is one of the properties of an electrode? An electrode must be what? An electrical what? Conductor. Okay. So it says it says an electrode is an electrical conductor that is used to make contact with what? With the metallic part of the circuit there. Okay. Then it says the anode is the electrode where what? Where oxidation takes place. Okay. The anode is the electrode where what? Where oxidation will take place. So the anode is the electrode where what? Oxidation will take place. So now how are we going to remember all of that? We can use what? We can use ox-N, whereby ox is what? Is oxidation, occurs what? So the N will represent what? The N will represent it occurs at the anode there. Then next it says the cathode. So the cathode, so this is our cathode compartment. The cathode is the electrode where what? Where a reduction will take place. Okay. So how are we going to remember all of that? We can use what? We can use red cat. So with red cat, what are we now saying? We are saying that reduction occurs where? Reduction occurs at the cathode there. Okay. So we are going to use all those words so that it is easier for us to remember in the examination there. Then in terms of oxidation, it says oxidation. So this is now just the summary again. We said oxidation is what? The loss of electrons. And how will we remember? We said we are going to use what? The word oil there. Then it says an increase in what? Or it can also be defined as an increase in oxidation number there. Okay, then oxidation, in terms of the oxidation half reaction, we are going to be having what then? The reducing agent. So remember we said that we are going to associate the reducing agent with what? With oxidation. So it says a reducing agent, a substance that is what? Oxidized, a substance that loses electrons, which relates to that oil, and whose oxidation number what? Whose oxidation number increases. Okay. Now reduction again, it says what? A gain of what? Electrons. And then oxidation can also be defined as what? A decrease in oxidation number. We spoke about that. We said we are moving from 2 plus 2 to 0. So therefore it's a decrease in oxidation number. And then we said that we can then associate what? Oxidizing agent with what? With reduction. Hence, that's why we define oxidizing agent as what? A substance that is what? Reduced. And then again, it says that a substance, it does what? In oxidizing agent, it gains what? Electrons. So we spoke about that. And then whose oxidation number does what? Whose oxidation number decreases there. And then what did we say about the agents? We said that as long as your half reaction in terms of oxidation and reduction is correct, the agents will be where? Will be your reactants, or they will always be where? On the left-hand side. Okay. So next we have what? We have half reactions. It says the oxidation and reduction processes can be written as what? Can be written as half reactions. Now it says you use the table of reduction potentials to write down the oxidation and the reduction half reaction with only what? So this is very important, with only a single arrow that is to represent what? Each half reaction. Okay. So remember with your table 4A or table 4B, it comes with what? It comes with 2 arrows. But when we have now finally decided that this one is my oxidation half reaction or this one is my reduction half reaction, you need to make sure that you are only going to use what? That you are only going to use a single arrow, not 2 arrows. Okay. Then it says the 2 reactions should be balanced. That is, they should have the same number of what? Of electrons. And then it says the net reaction is the sum of oxidation and the reduction what? Half reaction there. Okay. So now in terms of the half reactions, okay, you have your table 4A and your table what? 4B. But now I will only be using what? I will only be using the table 4B there. Okay. So with table 4B, on the left here, it says what? Increasing what? Oxidizing ability. And then on the right here, it says what? Increasing, reducing ability going up, and increasing oxidizing ability going down there. Okay. So you need to, for you to be able to do the half reactions, what is it that you are going to do then? You can use what? You can use the letter what? You can use the letter Z there, okay? So when you use the letter Z there, we are saying that half reactions are as easy as what? Half reactions are as easy as A, B, C there. So this will be your A, this will be your B, and then this will be your C there. So with those letters, what are you then saying? You are saying that whatever that you have there at the top, okay, of the table, it is going to represent what? It is going to represent your anode. Then with the letter B, which we will talk about later, we are saying that we are representing what? The salt bridge. Then with the letter C, what are we saying? We are saying that with the letter C, we are representing the cathode, okay? So whatever that you have identified at the top of the table is your anode. Whatever that you have identified at the bottom is your cathode. And then in between you have what? You have the letter B, which is your salt bridge there, okay? But this is only going to work. So ABC is only going to work if you use what? If you use table 4B. So if you use table 4A, it therefore means that you need to come up with a what? With a new formula. Hence, that's why I said that for this one, I will only be explaining what? Table 4B. But remember, in the examination, you can then choose for yourself. But as I've said, I will only be explaining with what? Table 4B there, as they're exactly the same, but you must just use what? You must just use a different formula there. Okay. So now let us say now, as an example, we want to use what? We want to use maybe zinc and what? Maybe zinc and nickel there. So it therefore means that we are going to draw our Z there, and the arrow of the Z must face where? For the first one, it must face to it must point to the left-hand side. And then let's say, as an example again, what are we using? We are also going to use nickel there. Where must the arrow point? The arrow of the nickel, it must point to the right, okay? So now with the half reaction, remember we said it's as easy as what? As ABC. So again, at the top, it means whatever that you have at the top, what does it represent? ABC, so A is your anode, B will be our salt bridge, and then C will represent what? C will represent your cathode. So now, how do we then write the half reactions? Okay, since we have this arrow here facing where? To the left, we are saying that when we write the anode, we are going to write the anode from the right, and then where do we go? We go to the left-hand side, okay? So remember, also for you to practice, you need to make sure that you have your own table 4B, okay? So now, what do we have on the left-hand side? We have Zn. So we write it exactly as it is. So we have Zn, but our arrow, what is our arrow saying? Our arrow is pointing where? Yes, it is pointing to the left, but it basically means that we need to point at what? We need to point at everything that we have there on the left-hand side. So what is everything that we have there on the left-hand side? We have Zn what? 2 plus by what? Plus by 2 electrons. And then what are we going to do? You write it exactly as it is. It therefore means that you are not going to leave out the charge, and then you are not going to leave out the what? The minus there for the 2 electrons. Okay, so that is how you would write your anode half reaction. Where are you starting? You started here with the Zn. Then what did you say? You said the arrow. Okay, so the arrow, it is going to point where? It is going to point to the right-hand side. But when it points to the right-hand side, then what are we saying? It needs to point at everything that we have there on the left-hand side. And what is everything that we have there on the left-hand side? We have Zn2 plus by what? Plus by 2 electrons. Okay, then we move on to the cathode. With the cathode, then, what are we saying? We are saying that we are going to copy and what? Copy and paste. So copy and paste, Then what are we going to write? We have Ni what? Ni2 plus by 2 electrons there. So now because our arrow is saying that we are going to write whatever that we have what on the right hand side. So what is it that we have on the right hand side? We have Ni. So that's exactly what we are going to write, okay? So again with the cathode, you are going to write exactly what is there. You are not going to remove the 2 plus, or you are not going to remove the what? The minus on the 2 electrons there. So that is how we write our what? Our half reactions. So even if, let's say as an example now, we had what? We had Pb2 plus, okay? Pb2 plus, there's our arrow. And again, we had what? Let's say again, we had, as an example there, let's say we had what? We had the copper there. What is it that we're going to do? It's as easy as ABC. So whatever that's at the top is your anode, whatever that's at the bottom is your cathode. Okay? So PB, since it's your anode, it means that you are going to write whatever that you have from the right to the left there. So what do you have on the right hand side? You start with your PB. Then you know that your arrow, remember it must be what? It must be a single arrow. So your arrow will then point where? To the right hand side. And then what do you have on the left? You write exactly what you have. So it's Pb2 plus by 2 electrons. Then you're going to move on where? You're going to move on to the cathode. With the cathode, what are we saying? We copy and paste. Copy and paste means what? We are going to write Cu2 plus by 2 electrons. And then we are going to write, remember, a single arrow. And then on the right, we have what? We have Cu. So that is how you write your oxidation and your reduction half reaction. Okay, whatever that's at the top is your anode. So even if it can be anything else, even if it can be, for example, again, even if it can be nickel and what? Nickel and the iodine there at the bottom. Okay, so the nickel will represent what? Your anode, and then the iodine will represent what? The cathode. Okay. Now it says here the zinc and the copper half reactions. It says the half reactions that take place at the zinc plate is that. So that means that this reaction is then written from what? From the right to the left. This is now the anode what? The anode electrode or the oxidation what? Half reaction. Then it says the half reaction that takes place at the copper plate can be represented by this. Cu2 plus 2 electrons to give us what? Cu. Okay, so it means that what happened here, if you look at your table 4b, the Zn represents what? Your anode. So if you use the Z like that, it means that you will find what? You will find the Zn at the top here, and then at the bottom you will find your copper. So if we use ABC, this is your anode, the salt bridge, and then this is your cathode. Okay. So hence that's why it says here, this is your cathode electrode. Okay. So now how do you do the net reaction there? You are going to write your what? For the net reaction, you are going to write your correct oxidation half reaction, which you get there from your table 4b, and then you are going to write your correct what? You are going to write your correct reduction what? Your correct reduction reaction. Okay, so you have your correct oxidation reaction and your correct reduction what? Your correct reduction reaction. Then what is it that you need to do? You just need to make sure that the electrons are what? The electrons are balanced, okay? So in this case, we have what? We have 2 electrons for zinc, and then we also have what? 2 electrons for the copper. So if your electrons are balanced, then the electrons can simply be cancelled out there. Once you cancel out the electrons, what is it that you are going to do? You are just going to write whatever that you have on the left-hand side and whatever that you have on the right-hand side. So what do you have on your left-hand side? You are left with Zn plus by what? Plus by Cu2 plus. So it is this Zn plus by Cu2 plus your single arrow, and then you are going to write whatever that you have on the right hand side. What do you have on the right hand side? You have Zn2 plus by what? Plus by Cu. So it's your Zn as a product, and it's your Zn2 plus as a product, and your Cu as your product. Okay. So what are we saying in terms of the net reaction? In terms of the net reaction, we are saying that number one, you need to make sure that you write your correct half reaction in terms of oxidation. Number two, your correct half reaction in terms of what? Reduction. Number three, you need to make sure that the electrons are what? The electrons are balanced. If the electrons are not balanced, then you need to make sure that you balance the electrons. Once we now see that the electrons are balanced, just to get them out of the way, we can just cancel out the electrons. So we can see that we have 2 electrons here, and then we also have 2 electrons here, so they are balanced. Then next, what are we going to do? You write whatever that you see on the left-hand side, okay? That is your reactant. What is it that you see? You can see that you have Zn. You write it exactly as it is. You don't add 2 plus or anything that you don't see. Then, what else do you have on the left-hand side, or as a reactant? You have a Cu2 plus. Then you write your Cu2 plus. Next, what are you going to do? You go on to the right-hand side. Why? Because there's nothing else that you can write on the left-hand side. So remember, everything that you do, it needs to be what? Single arrows. Then on the right-hand side, what is it that you are left with? You are left with Zn2 plus. Then you write your Zn2 plus. What else are you left with? You are left with Cu. So you write your Cu there. Okay. So you are not going to be adding anything extra which was not part of the oxidation and the reduction half reaction there. Okay. Then it says standard cell notation. It says here, in the cell notation, the anode or the oxidation process is always written where? On the left-hand side, and the cathode or the reduction process is always written where? On the left-hand side. Then it says spaces which are in contact are represented by a line. And then cell breach is represented by what? Cell breach is represented by a double line there. So we are still going to talk about what? We are still going to talk about the cell breach. So again, remember we said that if you want to write the oxidation and the reduction half reaction, what are you going to use? You are going to use your table 4a or your table 4b there, okay? But now what are we saying? In terms of the cell notation, or also with the table, we said that it's as easy as what? It's as easy as ABC, whereby we said A is the anode, B is the cell breach, and then C is the cathode. If it's as easy as ABC, then this one here, we said anode or the oxidation process. Where is it written in terms of the cell notation? It's written on the left-hand side. So again, cell notation, we are saying that it's as easy as what? As ABC. Whereby A, again, what does it represent? The anode. And then B, the same as this B here, what does it represent? So B is the breach or the salt breach there. Then what are we saying here? The C, so the same as that C there is our what? Is our cathode, okay? So if you want to identify on table 4b or table 4a, your oxidation and reduction half reaction, it's as easy as ABC. If you want to write your cell notation, it's also as easy as what? It's also as easy as ABC. Okay, so what is it that we did now? This was your oxidation what? Oxidation half reaction. We had Zn to give us what? Zn2 plus 2 electrons. So it means that the Zn was at the top. Hence, that's why the Zn went what? Through oxidation there. So if the Zn is your oxidation half reaction, then this is what we are saying in terms of the cell notation. You are going to write it, the cell notation, from the left-hand side to the right-hand side. Okay, so what is the first thing that you need to do when you write the cell notation? You need to make sure that you have a correct half reaction in terms of what? In terms of oxidation. That is the first thing that you need to do. And where do you get that half reaction? You are going to get it on table 4A or on table what? 4B. Once you now have the correct half reaction in terms of what? In terms of oxidation. This is now what you are going to do. That oxidation half reaction, you are going to write it from the left-hand side to the right-hand side. Okay. So what is it that you have on the left-hand side? On the left-hand side, you have what? You have Zn. So this one, it represents what? It's the phases. So S represents what? It represents a solid. So whenever you don't have a charge there, that will represent what? S, which is what? Which is a solid. Then when you have a charge, it will represent what? Aqueous. Okay. So those are the phases, solid and in aqueous solution there. Okay. So write it from the left to the right. So we can see that on the left, what is it that we have? On the left, we have Zn. So Zn what? Zn solid. So you write it exactly like that. Then on the right side of the equation, which is your product, what is it that you have? You have Zn2 plus what? Aqueous. You will write it exactly as it is. So it basically means that we have what here? Zn is our reactant, is on the left-hand side. Zn2 plus aqueous is our product because it's where? On the right-hand side. Then we are moving on to the copper. For the copper half reaction, what did we have? We had Cu2 plus by two electrons to give us what? To give us Cu. So it's Cu2 plus aqueous. We have a charge, so it will be aqueous. We don't have a charge, so it's going to be what? Solid there. So we are going to have what? We are going to have the double line, which represents what? The salt bridge. Then the Cu2 plus, how are we going to write it? The cell notation, we are going to write it from the left-hand side to the right-hand side. So what do we have on the left-hand side? We have Cu2 plus aqueous. So we write exactly that. Cu2 plus aqueous. Then we have a single line there. So a single line, what does it represent? That represents it's a phase separator. We are separating the two phases because you can see that here we have aqueous and then here we have a solid. So therefore, we are going to use the single line, the same as this one, solid and what? And aqueous. So that's a phase separator. So you need to make note of that. You can be asked to identify this line, so you will know it's a phase separator when you have a double line that represents what? Your salt bridge there. Okay, so we are going to write it from the left to the right. What do we have on the left? We said we have what? Cu2 plus aqueous, and then what do we have on the right? On the right we have Cu what? Cu solid. Okay, so again, it means for you to be able to write it from the left to the right. It therefore means that you would have started by writing the correct half reaction in terms of what? The correct half reaction in terms of a reduction there. Okay. Next we have what? Next we have the cell notation. So again, for the cell notation, I'm going to continue using the table 4B there. Okay. So we have the cell notation. And then again, let's say we use what? Let's say we use Zn and copper there as our examples. So what is the first thing that we are going to do? So just to remind you, we said that we are going to use what? Zn2 plus 2 electrons. And then we draw our Z there. So when we draw our Z, we are saying that how do we identify the half reactions? It's as easy as what? It's A, B, C. Okay, so if that's the case, we are therefore saying that we are going to write our oxidation half reaction. How do we write oxidation half reaction? It's going to be from the right to the left. So we have Zn, and then what do we have? We have Zn2 plus by 2 electrons, because our arrow is saying that whatever that we have, we need to point at whatever that we have on the left-hand side there. Then at the bottom, it's as easy as what? As ABC. So at the bottom, we have what? We have the cathode. So cathode, we said what? Copy and paste, but we use what? A single arrow. So it's going to be Cu2 plus by 2 electrons. So I'm copying and pasting, copy and paste. Then the single arrow to give us what? To give us Cu. So what did we say? We said that if we don't have the charge, we're going to have a solid there. If we have the charge is aqueous, we have a charge is aqueous. We don't have a charge, it's going to be solid. So again, we said the cell notation is as easy as what? As easy as ABC, okay? So if it's as easy as ABC, what did we say? It means that we are going to write it from the left to the right. So if it's the left to the right, we start with the anode. What do we have on the left? We have Z and what? Solid. Then what are we going to have? A single line which represents what? A phase separator. Then what do we have on the right? Zn, 2 plus what? Aqueous. Then what are we going to have? Because it's as easy as ABC. We are done with the anode, so therefore we are going to use what? The Sawbridge double line. Then we have what? The cathode. Cathode, we're going to write from the left to the right. What do we have on the left? Cu2 plus what? Aqueous. Now we have aqueous and what? And solid. So we need to use what? A phase separator. So we separate the two phases. Okay? Then what do we have on the right-hand side? We have a Cu what? Cu solid. Okay. So even if we can use what? Even if we can use ion and what? And let the Pb. Okay. So if we use that, we are saying it's as easy as what? SAB what? SABC now. Whereby the ion will represent the what? The anode. And then the lead will represent what? Will represent the cathode. So what are we going to do? The anode we are going to write from the right to the left. So it's going to be the ion to give us Fe2 plus by 2 electrons there. So on the left, we don't have a charge, so it's going to be solid. On the right, we have a charge, so it's going to be aqueous. Then what do we have? The lead represents the cathode. Cathode, we copy and paste. So it's going to be Pb2 plus by 2 electrons to give us what? To give us Pb. So again, we have a charge. If we have a charge, is what? Is aqueous. If we don't have a charge, is what? It's solid. Then we need to write the what? We need to write the cell notation. So the cell notation is as easy as what? It's as easy as A, B, C. Then we check again. What do we have on the left-hand side? So on the left-hand side, we have what? We have ion, solid, that is in terms of what? That is in terms of the anode. Then we can see that we have a solid and what? An aqueous. So we're going to use what? A phase separator. So that is Fe and then Fe what? 2 plus what? Aqueous, okay? Then we said it's as easy as ABC. So the B is what? Sawbridge. How do we represent Sawbridge? We are going to use double line there. Then we have lead or Pb. Pb, we are going to write it from the left to the right. So what do we have? Pb2 plus, sorry about that. What? Aqueous, and then what? And then the phase separator, because we have aqueous and what? And solid. So phase separator on the right, what do we have? We have Pb what? Solid. Okay. So that is how we do our, that is how you write your cell notation there. Okay, so now it says here, an electrolyte is a substance of which the upper solution contains ion. Okay, so we have 2 half cells here, and on these 2 half cells here, we have what? On these 2 half cells, remember we spoke about this, we said we are going to have what? We are going to have the anode, and we are also going to have what? We are also going to have the cathode there. But then with the electrolyte, it says a substance of which the upper solution contains what? The upper solution. So this would represent our electrolyte. And this here, it says here 1 molar, which is the concentration solution of what? Of copper 2 nitrate. So that is our electrolyte. It contains ions. Why? Because now you have what? You have Cu, NO3 and 2. When you break it down, it becomes what? Cu2 plus and NO3 what? Minus there. So this electrolyte or this solution, it contains ions. So those ions are what? We have your cations, which are positive, and your anions, which are what? Which are negative. Or it says a substance that dissolves in water. So this copper 2 nitrate, it's our electrolyte. It is a substance which is going to dissolve in water, and that is to give a solution that does what? To give a solution that conducts electricity. So this substance here, on the left-hand side, we have what? We have copper 2 nitrate as our electrolyte, and it's going to break down to give us what? To give us ions. On the right-hand side, we have what? We have silver nitrate, which is what? Which is your AgNO3. And the silver nitrate is going to break down into Ag plus and NO3 minus. So that solution is, it contains what? It contains ions. Ions which are your cations, which are positive, and your anions, which are negative there. Okay, now it says here, so now this is now explaining what? This is now explaining the galvanic cell. So it says a galvanic cell consists of what? It consists of two half cells, okay? So we have two half cells that are going to be in the two beakers there. And these two half cells are separated by, remember we've been speaking about what? We've been speaking about the salt bridge. So this would represent your salt bridge there. These two half cells are separated by a salt bridge, okay? And then it says there are electrolytes which have the same ion as the metal used in the electrode there. So remember we spoke about the electrolyte. In this case, what do we have as our electrolyte there? We have our zinc sulfate, which is ZnSO4. This ZnSO4 is going to break down into solution Zn2 plus to give us Zn2 plus and SO4 what? SO4 2 minus, okay? So it says there are electrolytes which have the same ion. So this ZnSO4 is going to break down into Zn2 plus, Zn2 plus and SO4 2 minus. It says there are electrolytes, ZnSO4 is your electrolytes, which have the same ion that is used in the electrode. So when the ZnSO4 breaks down, what does it have? It says which have the same ion which is used as the electrode. What do we have as the electrode? We have Zn. So it says this electrolyte, the ZnSO4, it will then have the very same what? It will then have the very same ion, which will be the same as your electrode. So even on this side with the copper, when the copper breaks down, it gives you what? Cu2 plus and what? And SO4 2 minus. So it therefore means that we are going to have, in the electrolyte, we are going to have the very same ion, which is the same as what? Which is the same as your electrode. Because on this side, what do you have? You have Cu or copper as your electrode. Then it says the electrodes are connected to a galvanometer. So these are the electrodes. We have zinc and we also have what? Copper. They are connected to a galvanometer or to a voltmeter. So a voltmeter will therefore read the what? It will therefore read the voltage via the what? Via the external circuit, okay? So these two electrodes, they are connected with a voltmeter or a galvanometer via the external circuit. Now it says the salt bridge. So this is now the salt bridge, the tube here. Salt bridge consists of a salt solution In this case, what do we have as our salt solution? In this case, we have what? We have KCl. So it consists of a salt solution which allows for the movement of ions between the two cells. So with this one, how is it going to be ions? It's going to break down into K plus and what? And Cl minus. Because you will see that you find your potassium on group number 1, so it has a charge of what? Plus 1. Then you will see that you find your chlorine on the periodic table on group number 7 or group number 17. So therefore it will have a charge of what? Of minus 1 there. Okay, so it says it will allow for the movement of ions because the KCl will then break down into ions, okay? But we are going to talk about that later then. Okay, then it says in a galvanic cell, the anode is a negative electrode. So very, very, very important. You need to know if they ask about what is the polarity of this electrode. Then they're asking, is the anode negative or is the cathode negative or positive? So the anode is a negative electrode where oxidation takes place. But the cathode, so the anode is the negative electrode, but the cathode is the positive electrode where what? Where reduction takes place. Okay, so anode, negative electrode where oxidation takes place. The cathode, positive electrode where reduction takes place. How are you going to identify which one is the anode, which one is the cathode? Remember, you are going to use what? Table 4b there. Okay. Now it says here the electrode is placed in an electrolyte with similar ions. Okay. Okay, learners, I'm going to ask that we take a 1-minute break there. Okay, welcome back, learners. So if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. If you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908 there. Okay, so it says here the electrode is placed where? So this is your electrode. It is placed in an electrolyte that has what? With similar ions. So we spoke about that as an example. We are saying that zinc is placed, so this is your zinc electrode, is placed inside a zinc solution. Okay, so again, if you were to represent your anode half reaction, then it would be what? It would be Zn to give us what? Zn2 plus by 2 electrons there. So this would be your anode half reaction, and then this would be your cathode half reaction. So it would be Zn solid and Zn2 plus aqueous. This one would be Cu. It would be Cu2 plus what? Aqueous, and then Cu what? Cu solid. So if this is your anode, if Zn is your anode, it therefore means, what did we do? It's ABC. So it therefore means that the Zn was at the top, and then the copper was where the copper was at the bottom. That is why the copper is acting as your cathode there. Okay, so now in terms of the explanation, it says in the zinc copper cell, The copper and the zinc plates are used as what? They are used as electrodes. So we spoke about that. We said we are going to use what? We are going to use copper and zinc there as the electrodes, okay? Then it says zinc plate is the anode where oxidation will take place. But the copper plate, so now this is the copper plate, is the cathode where what? Where reduction will take place. Now, how did we identify that? We said we used what? We said we used ABC, whereby A is your anode, B is your salt rich, and then C is your cathode. So now what happens in terms of the copper plate? This is what is going to happen. It says there will be an increase in what? There will be an increase in mass, okay? So this one here, it represents your zinc, which is your anode. This one represents your copper, which is your cathode. So when the two reactions are taking place, oxidation and reduction, remember we said that they are going to occur simultaneously, meaning at the same time or at exactly the same time. So as they are occurring, what is happening? The Cu, which is the copper. So if initially it was like this, then after some time, we are saying that the Cu is going to do what? Is going to increase in what? Is going to increase in mass. Okay, so it says this means that the Cu2 plus ions, so the Cu2 plus ions, these ones here, they are blue in color. So they are going to move, this means that the Cu2 plus ions from the copper sulfate solution, so from the electrolyte, are deposited onto the plate as atoms of what? Of copper metal. So we are saying that they are going to move to the electrode. So if you are going to use the reaction to explain, we have Cu2 plus aqueous plus by 2 electrons. This is your cathode half reaction. This is what we are saying. So it says this means that the Cu2 plus ions, which are blue in color, this is the Cu2 plus ions and they are blue in color. It says from the copper sulfate solution. So the Cu2 plus ions from the electrolyte are deposited, or they are going to move toward to the copper metal. So Cu2 plus will move to Cu solid. So we are saying that Cu2 plus aqueous, it is in what? It is in the electrolyte, it is in solution. It is going to move to the electrode. So as Cu2 plus aqueous moves to Cu solid, then the copper electrode will do what? Will increase in mass there. Okay. Next, we have the zinc plate. It says what is now going to happen at the zinc plate. At the zinc plate, there was a decrease in what? There was a decrease in the mass there. Okay. So with the zinc, we are saying that we are moving from Zn solid because it's the anode half reaction, Zn solid to Zn aqueous plus by 2 electrons. And then with the copper, it was Cu2 plus aqueous plus by 2 electrons to give us what? Cu solid. So at the zinc plate, we are saying that there's going to be what? There's going to be a decrease in the mass, okay? So if initially this was the zinc plate, then as the two reactions are occurring, the zinc plate is going to decrease in mass. It says this means that some of the zinc goes into the solution as what? As Zn2 plus. So what are we saying now? We are saying that when it comes to the anode, the Zn solid, so Zn solid, it means it's moving from what? It's moving from the electrode to Zn2 plus, which is in the solution. So here we are saying that this is the electrode. We are moving from Zn solid, and then where are we moving to? To Zn2 plus aqueous in solution. On this side, what are we saying? We are saying that the Cu2 plus aqueous is moving from the electrolyte to what? To the electrode. So on the copper side, we are moving from the electrolyte to the electrode. On the anode side, we are moving from the electrode to the electrolyte. So as we move from the electrode to the electrolyte, there is a decrease in mass. On the copper side, as we move from the electrolyte to the electrode, there is an increase in mass. Anode, electrode to the electrolyte. Cathode, electrolyte to the electrode, increase in mass. Okay, learners. And then this then says this is the anode electrode. So the anode represents what is represented by the zinc there. Then it says here in the Zn or Zn2 plus, there's going to be a build-up of what? Of positive charge. Why? So we are saying that we are moving from Zn solid to Zn2 plus by 2 electrons. That is your oxidation half reaction. Then we are saying what happens as we move from the electrode. So we are moving from the electrode to the electrolyte. We said there's going to be a decrease in mass. When there is a decrease in mass, what is happening again in the electrolyte? It therefore means that we are going to have a lot of this Zn2 plus in solution. Okay. Now with the cathode, we have Cu2 plus by 2 electrons to give us Cu. So therefore, we are moving from what? From aqueous to solid. Aqueous to solid. So it therefore means that there is going to be a decrease in number. Why? Because the Cu2 plus are moving from the solution to the electrode. So we are going to have a small number of the Cu2 plus, but on the anode side, we are going to have a lot of what? We are going to have a lot of the Zn2 plus. So it says here in the Cu2 plus or Cu half cell, there is a decrease in the positive charge because electrons are gained through reduction. Okay. So again, what do we have there? Remember, we said that we have a voltmeter there, which is going to read your voltage. But how do we then get the voltage there? Electrons are going to be moving from the anode to the cathode. Okay, so this is one of the possible exam questions. They can ask you, where do electrons move? Electrons, remember we said in terms of the cell notation, it's as easy as ABC. So electrons are going to move from the what? In terms of the galvanic cell, electrons are going to move from the anode to the cathode. So you can also draw an arrow for yourself there so that you can remember. So as now, there is now what? There is now a flow of electrons. What is happening? As there is a flow of electrons, we are going to have a build-up of the Zn2 plus. Why? Because we have Zn solid moving into Zn2 plus, that is into the solution. When that happens, we are saying there's a build-up of what? Of Zn2 plus. And then on the right-hand side, that is in terms of the cathode, what is happening? We are saying that the Cu2 plus will move from the solution to the electrode. When that happens, then it therefore means that we are going to have a small number of what? A small number of Cu2 plus in the cathode compartment then. It says then this causes a movement of chloride ions of the electrolyte into the beaker, where there are too many positive ions, that is in order to neutralize the solution. Then it says without this, the flow of electrons in the outer circuit is going to stop completely. Okay. It says the U-tube core, the cell bridge, acts as a transfer medium that allows for the flow of, that allows ions to flow through without allowing the different solutions to do what? To mix. So remember we said that we have what? We have a salt bridge there. This salt bridge, it contains what? It contains NaCl there. So NaCl, sodium, it has a charge of what? +1, and then chlorine has a charge of what? -1 there. Okay, so we are saying that S on this side, there's going to be a build-up of the Zn2 plus, Zn2 plus, and then this side there's going to be a small number of the what? Of the Cu2 plus. It then says here, this causes the movement of the chloride ions of the electrolyte into the beaker where there are too many positive ions. So we are saying that the chloride ion in this case will therefore want to move where there's a lot of what? Positive ions. Remember we said on the anode, there's a lot of positive ions. So to neutralize, the chloride ion will move where there's a lot of positive ions because the chloride ion is what? Is negative. Then to neutralize on this side, what is going to happen? On this side, we are going to have a small number of the Cu2 plus ions because Cu2 plus moves to the electrode. When that happens, what are we left with? We are going to be left with a lot of what? NO3 in solution. And those NO3 in solution, they are negatively charged. So because they are negatively charged, it therefore means that the sodium will want to move where? Will want to move on the side where there's a lot of what? Where there's a lot of negative charges. Then maybe you might ask yourself, what are the NO3 participating or what are the functions of the NO3 in the reaction? The NO3 in the reactions are your spectator ions. If there's your spectator ions, it therefore means that they are not going to participate. That is in terms of your what? That is in terms of your half reactions. They will just participate whenever you have what? Whenever you have your Sol bridge, and that is to neutralize. Okay. So just to summarize again, we are saying on the anode, there's going to be a build-up of Zn2 plus ions. Therefore, the chloride ions will want to move to the side where there's a lot of positive charges. On the cathode side, there's going to be a small number of the positive charges, but there's going to be more of the NO3 minus ions. Then it therefore means that the Na plus, because it's positive, it will want to move to the side where there's a lot of what? Negative charges. Then it says in the zinc half cell, electrons leave the anode and flow through the external circuit or wire to the cathode. So remember we said the flow of electrons, if we use ABC, the flow of electrons is from the anode to the cathode. So flow of electrons from the anode to the cathode. And it says as the electrons leave the anode, the cations or the positive ions form dissolve into the solution in the anode compartment. So we are saying that as there is a movement of electrons, then we are going to have what? We are going to have oxidation half reaction, and then we are also going to have what? We are also going to have the reduction half reaction there. Okay. Then it says once electrons flow from the anode to the cathode, the charges in each beaker would not be balanced, and the flow of electrons will what? The flow of electrons will stop. So that is what we explained to say that there's going to be a buildup of what? There's going to be a buildup of Zn2 plus, Zn2 plus, Zn2 plus, and then on this side we said there's going to be a buildup of what? Of NO3 minus on this side, okay? So it says once electrons flow, so once we have a flow of electrons from the anode to the cathode, the charges in each beaker would not be what? Would not be balanced. Because we spoke about this, we said this side there will be a lot of positive charges, this side a lot of negative charges. And it says therefore the flow of electrons will do what? It will stop. Unless what? Unless we use a Sol bridge. It says therefore we use what? We are going to use the Sol bridge, which is usually a U-shaped tube that contains a salt solution. So the salt solution in this case would be represented by what? By the sodium chloride, and that is to do what? The Sol bridge will help us to keep the charges balanced there. Okay. Now it says here, just to make it clear again, the negative ions are called the N ions. So Cl minus is a negative ion, NO3 minus negative ions, And then the positive ions are called the what? The positive ions are called the cations. So Na plus, it's a positive ion, and then Cu2 plus positive ion, Zn2 plus is a positive ion. So what is going to happen in terms of the Soul bridge? So it says the cations move towards the cathode. So it therefore means it's what? It's cat there. So cat, what are we saying? The cations which are positive, where are they going to move to? They are going to move to the cathode. Then in terms of the anions are negative. So again, it's what? It's Nn. So Nn, what are we saying? We are saying that the anions which are negatively charged, where are they going to move to? They are going to move to the anode. So we need to keep that in mind in terms of the movement of the what? In terms of the movement of the Soul bridge. Okay. So you can be asked that question to say, explain the movement of the anions, where the anions going to move. Then you will know that the anions will move to the anode because it's Nn, and then the cations will move to the cathode because we are going to use what? Cat there. The Soul bridge now, it says in electrochemistry, is a laboratory device that is used to connect the oxidation and reduction half reaction of a galvanic cell. Okay, so this is now the Soul bridge. We spoke about that. So it's a laboratory device, okay, that is used to connect what? The two half reaction, that is your oxidation and your reduction reactions there. So functions of the Soul bridge: to complete the circuit by connecting the electrolytes in the half cells. So if we do not have what? If we do not have the Soul bridge, it means that the cell is what? The cell is incomplete. Now it says to complete, okay, so it means that the cell is not complete. Number two, to allow ions to flow through. So we spoke about ions are going to flow. We said the anions to the anode, the cations to the cathode. So to allow those ions to flow through, but that is without allowing what? The different solutions. So we have the two electrolytes. We are going to allow these ions to be able to flow through, but without allowing the two electrolytes in the anode and the cathode compartment to mix and to react. Number three, to help to maintain what? Electrical neutrality of the electrolytes in the half cells. How is it going to help us? Remember, we said that in the anode compartment, we are going to have a buildup of what? Of the Zn2 plus S. Electrons are moving, and we are having what? The oxidation half reaction. There's going to be a buildup. This side, what did we say? So if we have a copper sulfate as the electrode, CuSO4, it therefore means that the copper sulfate will form what? Will form an electrolyte that is Cu2 plus and SO4 minus. That means that in the cathode compartment, what are we going to have? We're going to have a buildup of SO4 minus in the cathode compartment. So if we have a buildup of SO4 minus, what is the Soul bridge going to help us to do? Is to maintain that electrical neutrality between the two by doing what? Because on the anode, we said there will be a buildup of the positive charge. We said the anions. So it means that now a lot of Cl minus will then move where? A lot of Cl minus will then move to the because they are anions. Anions will move to the anode. We said Nn. And then the cations, because the cations are what? Because the cations are positive. And we have SO4 minus, which is the spectator ions, which do not participate in what? We said they're not going to participate in our half reactions. Okay, so because on the cathode we had a buildup of the SO4 minus, the K plus will then move where? Will then move to the cathode side. So K plus is what? Is a cation will move where? To the cathode, because we said what? Cat. So therefore we will end up having a lot of K plus there on the cathode side. So that number 3, it will help us to maintain the electrical neutrality. And you also need to make sure that for the exam, you know all the functions of the what? All the functions of the salt bridge there. Next, we have the EMF. It says the potential difference between the anode and the cathode in a cell is called the what? Is called the EMF or the cell potential there. Now, where are you going to get that? You're going to get that from your formula sheet. And then it says the cell potential is designated what? E cell. It says cell potential is measured in watts, so very important. Whenever you do your calculations, you need to make sure that you write your what? Your correct unit. That unit is what? Is volts, or the letter, capital letter what? V there. Then it says the cell potential at standard conditions can be calculated by, so we have E cell is equals to E cathode minus E anode. Now, how do you then use this? Remember, you would have used what? You would have used what? Your AB, your ABC there. So you would have identified your anode, you would have identified your cathode, and then you go on to table 4B, and then you are able to substitute those values there. So on your formula sheet, you will see that if you have the cathode represents what? Reduction. And then if you have your cathode, it represents your oxidizing agent. And then if you have your anode, it represents your oxidation, and then the anode also represents your reducing agent there. So you can then be able to use any of those formulas there. Okay, standard conditions that you need to use for those cells. So it's going to be temperature, which is 298 Kelvin or 25 degrees, and then your concentration, which is 1 mole per cubic decimeter there. Then you need to also make sure that you know the standard conditions, and it can be in your exams for maybe 2 marks there or 1 mark there. Okay. Now it says here, which one of the following combinations is true about the substance that is what? That is oxidized. So what is it that we're going to use? We're going to use what? Oil there. So oil, we said what? Oil, we said oxidation is what? Oxidation is loss. Okay. So if oxidation is lost there, what is it that we need to look for? It says which one of the following combination is true about the substance that is what? That is oxidized. So we know that number 1, we are going to use this, okay? So if oxidation is lost, it means that we then need to look for the weight loss there. So we have 2 gains and 2 losses. So the first thing is we are going to eliminate A, and then we're going to eliminate what? C as well there. So if oxidation is lost, number 2, what is it that we know about the oxidation number and a substance that is oxidized? So number 2, we know that the oxidation number does what? The oxidation number increases. So it therefore means that we're also going to eliminate what? We're also going to eliminate what? B there, because we said that B and D were our possible answers. Why? Because we firstly identified the what? The loss there. But what is it that we know about oxidation? It's an increase in what? In oxidation number. So it therefore means that our correct answer will be what? Our correct answer will be D. Because oxidation is loss of what? Electrons. And in terms of oxidation, it increases in oxidation number. Then, so all of these multiple choice questions are taken from what? From your previous question papers. Okay. So it says, which one of the following is correct about the change in mass of electrodes in a galvanic cell? It says that assume that both electrodes are what? Are solid metal. So what is it that we know? We know that in terms of the anode, there's going to be what? As the electrons are moving, what happens to the electrode? The electrode is going to decrease. So it means that we are going to eliminate whatever that talks about increases, that is in terms of the anode. Okay. So if there's going to be a decrease in mass as the electrons are moving, what is going to happen to the cathode? It therefore means that there's going to be what? There's going to be an increase. So it therefore means that B is also not correct there. Why? Because we are saying anode, there's a decrease in mass, and then as the electrons are moving, what happens to the cathode? The cathode becomes bigger and bigger, because remember when we use copper, we said it moves from Cu2 plus aqueous to Cu solid. Therefore, it was increasing in what? Increasing in mass there. Then next it says the cell notation for a standard ZnCu electrochemical cell is. So what is it that you are going to do? It therefore means that you are going to use your table 4b, then you use what? That it's as easy as what? As ABC. So whereby A is your anode and then C is your cathode. So if you use your table 4b, you will see that your Zn is where? Your Zn is at the top of the Zn. It's at the top of your Cu. So what is it that you are going to do? You are going to use your arrow there, okay, your Z there, and then at the top we are saying it's as easy as what? As ABC. That's also for the what? For the cell notation. Then remember we said what? You are then going to write your oxidation half reaction. So remember oxidation half reaction, you write it from the left to the right. So what is it that you have on the right? You have Zn solid because there's no charge, to give us Zn2 plus aqueous because we have a charge, plus by 2 electrons. And then what did we say about the cathode? You copy and paste, but remember to write the single arrow. So Cu2 plus aqueous plus 2 electrons to give us what? Cu what? Solid. Then we are saying the cell notation is as easy as ABC. So it means for A, we represent the what? We represent the anode. What do we have on the anode? We have Zn solid, phase separator. So from the left to the right. Then on the right, we have Zn2 plus what? Aqueous, SAW bridge. Then the cathode is what? Is Cu2 plus what? Aqueous, phase separator, and then Cu what? Cu solid. Okay. So then we can then go and look at the options that you have there. What do we have on this one? We have Cu2 plus first on the left-hand side. So it means that the copper is our anode. So if we look at our own cell notation, we will see that the zinc is the anode. So it means that A automatically there is incorrect. Then we move on to what? We move on to, let's move on to C. C, we'll see that it has a combination of Cu solid and Zn2 plus. So again, it means that this is incorrect. Then let's move on to D. What is happening in terms of D? D, yes, it has a Zn solid, Zn2 plus, which is what we have. It has a SAW bridge. But on the right, what do we have? We have Cu solid first. But the Cu solid, where should it be? It should be at the end. So it therefore means that D is also incorrect. Then we move on to what? To B. We will see that B has what? Zn solid and Zn2 plus aqueous on the left. SAW bridge, Cu2 plus aqueous, Cu solid. So therefore, B will be the correct answer there. Okay. Then it says in the cell notation of a galvanic cell, the double vertical lines represent the, so we just spoke about that. We said the double line, it represents the what? It represents the SAW bridge there. Because remember, cell notation, we said it's as easy as what? It's ABC. So whereby we said the A is your anode, the B, which is the double line, is your SAW bridge, and then C is your cathode there. Now it says here, 6.1, the cell notation. So we are given Zn solid. So the very same cell notation represents a galvanic cell that is operating under what? That is operating under standard conditions. 6.1.1, define the term what? Define the term galvanic cell there. Okay. So remember, in terms of the what? In terms of the definitions, we need to define according to the we need to define according to the examination guidelines. So it's going to be what? An electrochemical cell that converts what? Your chemical energy to electrical energy there, okay? Then 6.1.2, it says draw a label diagram to represent the Zn Cu cell, show the direction of the electron flow in the external circuit. So it means for you to be able to draw the diagram, then you must be able to realize and understand that the Zn is your anode and then the Cu is your cathode today. Okay, so that is our definition there. Okay, and the Cu is our cathode there. So what is it that you are going to have? You need to represent what? You need to represent the anode and electrode and also represent the cathode electrode. Then you need to make sure that you have the external circuit there, which has what? Which has a voltmeter. Then again, you need to make sure that you indicate what? The direction of the electrons. So where are the electrons moving? We said it's as easy as A, B, C. So also the electrons are moving from the anode to the cathode. So again, you just need to make sure that you are able to represent the two beakers, which represents the two half cells. And then again, you need to indicate what? You need to indicate the electrolyte. So on this side, on the anode, we are using zinc. And we also have an ion which has what? Which has zinc there, which is your Zn2 plus. On the right hand side, what are we using? We are using a copper electrode. So the electrolyte will also have an ion, which is the same as what? Which is the same as the electrode. And then remember, you also need to make sure that you indicate what? The Saw bridge, because if you don't show the Saw bridge, it therefore means that the cell is what? The cell is incomplete there. Then the next one says the cell notation. Okay, Zn solid, Zn2 plus aqueous to give us Cu2 plus aqueous, and Cu solid represents a galvanic cell that is operating under what? Under standard conditions. 6.1.3 says write down the two standard conditions under which the zinc copper cell operates. So remember, it's going to be your the two standard conditions is going to be your temperature and your concentration there. Okay, temperature and the concentration. 6.1.4, it says to which half cell do the N ions in the salt bridge migrate? So remember, we spoke about that. We said N ions are going to migrate to the what? To the anode. Okay, because we used what? We used NN. Okay, so it said the anode in this case. Remember, this is a cell notation. So we are saying it's as easy as A, B, C. So the anode is represented where? On the left-hand side, Saw bridge and the cathode. So therefore, the N ions are therefore going to migrate where? On the side where we have the anode half reaction. Where do we have the anode half reaction? It's going to be towards the zinc half cell, which is the anode. And then why does that happen? It says explain the answer to question 6.1.4. So why does that happen? Then you need to then speak about what? The function of the Saw bridge. So why do we have the movement of those N ions? It is to neutralize. Okay, so it says to maintain what? Electrical what? Neutrality. Remember, we said in the anode compartment there's going to be a buildup of what? Of positive charges. So if we want to neutralize them, we then need to be adding what? We then need to add the N ions from the Saw bridge. So to maintain electrical neutrality, because the zinc half cell, yes, it becomes what? It becomes more positive as zinc is oxidized to form what? Zn2 plus ions. So as Zn2 plus is moving from, so as we have what? Zn solid going into Zn2 plus, so as it is moving into solution there. Then it says the anode in the ZnCu cell is replaced by an unknown electrode X. The voltmeter gives a reading of what? Of 2 volts. Identify electrode X by means of what? By means of calculation. So what are you going to do? You are going to use your your formula sheet there, which is what you are going to use your formula sheet. So you will see that you have E cathode minus what? Minus E anode. Then what does it say? It says the anode in the ZnCu cell. So what did we have as our anode? As our anode, we had what? We had the zinc. So the zinc was the anode, and then the copper was what? The copper was the cathode. So now it says that anode is replaced by an unknown electrode X. Okay. So if the anode is replaced by an unknown electrode, what are we then saying? We are saying that we no longer have what? We no longer have the anode. Then it says the voltmeter reading, it gives a reading of what? Of 2,00 what? Volts. So if the voltmeter reading gives that, it says identify electrode X by means of what? By means of calculation. Okay, so what did we have? We had the anode, which was zinc, and then we had the cathode, which is what? Which is the copper there. So if the copper was the cathode, it therefore means that the E cell value for the copper is what? Is 0.34. Now we need to identify what? We need to identify that electrode X. So what are we going to do? We're given the reading, so we substitute the value of the cathode as well. What are we calculating? We are calculating the unknown X, which is the anode. So we will therefore see that the answer that we get, if we then take what is it that we're going to do? If we then say 2 minus 0.34, it will give us a positive what? Positive 1.66. And then we divide both sides by -1. We are therefore going to get a value of what? Negative 1.66 watt of volts. So if you look at your table 4b, you will see that on table 4b, then your electrode will therefore be what? Your electrode will therefore be the aluminium. Then it says write down the half reaction taking place at the anode. So remember, on 6.2.1, what did we do? We then identified that electrode. We said that electrode is what? Is aluminium. After identifying, we already had the copper. So we said, how do we identify? It's going to be ABC. So if aluminium is therefore our new anode, because it's at the top, it says write down the half reaction. What are we going to do? We are going to use the Z there to write the half reaction. With the Z, we are saying we are going to start with aluminium solid, and then on the left-hand side, what is it that we have? Al3 plus by 3 electrons. So that will represent the half reaction that is taking place at the anode. Why? Because we said the aluminium will therefore be our new what? Our new anode. Okay. Then it says the anode in the ZnCu cell. Okay. So 6.2.2. So we did this one right down there. The half reaction that is taking it there. Okay. So we've answered this one. Okay. So we've answered this one, and then we said that electrode X is what? Is aluminium. It's going to be our aluminium, or Al there. Okay. Then 6.2.3, it says which electrode will experience what? Which electrode will experience a decrease in mass? So we said which one experiences a decrease in mass? We are comparing aluminium with what? With copper. Aluminium is the anode, and then ABC. So it's ABC. Aluminium is the anode, and then copper is the cathode. Which one will decrease in mass? It's going to be the aluminium there, or the Al, or the anode, or the negative electrode. So it says explain the answer to question 6.2.3 there. Then what is it that we know about the anode? That is where what? That is where oxidation takes place. So the aluminium will be oxidized or what will happen? We can use oil, or there will be what? There will be a loss of electrons. That is in terms of what? That is in terms of the aluminium there. Okay, so the next one says the diagram below represents what? An incomplete, so an incomplete ZNCU galvanic cell. 6.1 again, we need to define a galvanic cell. So we said it's an electrochemical cell in which chemical energy is converted to what? To electrical energy. Then it says what will be the reading on the voltmeter. So we can see that we don't have what? We don't have the salt bridge there. So if we don't have the salt bridge, it therefore means that the cell is what? Is incomplete. So if the cell is incomplete, then we are saying that what will be the reading there on the voltmeter? So the reading will therefore be what? It will therefore be 0, because we will not be having the movement of what? Of electrons there. And then explain the answer to question 6.2. Remember, we said the cell bridge is doing what? The cell bridge is completing the cell. So the cell is what? Or the circuit is what? Is incomplete. And then there is no movement of what? If there's no movement of electrons, if the cell is incomplete, therefore the reading should be what? Should be 0 on the voltmeter there. Okay. Then next it says write down the name of the missing component. We said what is the missing component? It's going to be the salt bridge. Okay. What is the function? We spoke about this. We are saying it's to complete the circuit, to maintain electrical neutrality, and to provide a medium that allows what? That will allow. So if, for example, we had a KCl, it will allow for the movement of ions to flow through the cell what? Effectively, and that is without the two electrolytes doing what? Mixing up there. Then the next one said the ZNCU is now complete. In which direction will the electrons flow? So if it's complete, it therefore means that we now have what? We now have a salt bridge. Now, if it is complete, where are the electrons going to flow? Remember, if you use A, B, C, electrons are going to flow from where? Electrons are going to flow from the anode to the cathode. Okay. From the anode to the cathode, yes. Then 6.6.2 give the standard conditions under which the cell operates. Remember, standard conditions, where we said that is going to be your temperature, and then you mention your temperature there, and it's also going to be your concentration there. Okay. Then write down the net reaction of the cell. So how are you going to write the net reaction? You firstly need to identify your half reaction, that is in terms of oxidation, and then your half reaction in terms of what? In terms of reduction. So we said that how will you do that? It's as easy as what? As ABC. So the zinc is at the top, so it's your anode, and then the copper is at the bottom, it is your cathode there. So from there, what are you going to do? You check the electrons, they are balanced. Then you write what's on the left, plus by Cu2 plus what? Aqueous, arrow to give us what? Zn2 plus aqueous plus by Cu what? Solid. And then in terms of the cell notation, once you have your two half reactions, what is it that you have on the left? You have Zn solid, Zn what? 2 plus aqueous, because we are going to write it from the left to the right, to give us what? Cu2 plus aqueous, and what? Cu what? Cu solid there. So this one here would represent your cell notation there. Okay. Then it says the table below shows two half cells A and B used to assemble a galvanic cell under standard conditions. Okay. So learners, 5.1 says state the energy conversion. So it's going to be what? Chemical energy to electrical energy. Okay, so learners, we have ran out of time, and you can then just go through the following at your convenience. For now, learners, I would like to leave you with the words of Nelson Mandela, which says, "It is in your hands to create a better world for all who live in it." Thank you very much, learners, and I'll see you next time from here. Thank you.